All right, so today I want to talk about measuring some nominal cylinders, projecting them to a surface to form a circle, and then inspecting them using just a single point circle, so just taking one measurement point. So we're going to start by bringing in our model, and in this case I'm going to use our demo part, which you might be familiar with. I'm just going to bring in just the two surfaces that I care about here, and just hide this frame, which is a little bit large. I'm going to set our rendering to solid plus edges, just makes it a little bit easier to see. And you may already have some nominal points that you're going to align to. You could also do a quick align to CAD, but I'm going to go ahead and create some points that I can then measure. So I'm just going to go to construct, objects from surface faces, points, center points, and I'm going to add an offset of 1 inch. So that'll mean that I can measure these points. I'm going to measure these holes right here, but I'm going to offset them 1 inch so they'll be at the center of my SMR with a 1/4 inch pin nest. So I hit OK there, and then I just select inside the cylinders, and it starts creating those points. I'm going to do 6 points here, and you'll see that as I click inside, the point is created. And then just one more on the side over here. Okay, so now I have some nominal points that I can measure and then tie into using the instrument. So I'll go ahead and add the instrument. Just going to be using an API for demonstration purposes, and then run an instrument simulation. So I don't have the tracker here. I'm just going to uncheck connect to it. So then before we start measuring that, I'm just going to go ahead and create my task list, just to let you know that so you can do all of this off-site before you ever actually start measuring the part. So I'll go to the relationships tab in the toolkit, and I'm going to, what I'll do is I'm going to measure this hole, and these 4 holes in this bolt pattern here. So what I need to do is just create a relationship for each one of those that I'm going to measure. And I want to compare it to the CAD model. So I want to measure a diameter and a location, and I want to compare it to the nominal diameter and location. And that's really simple to do. So I'm just going to select a plane first, and that is using this plane from CAD here. And so I'm going to measure that plane, and that's going to allow me to project my cylinders to that plane. So for these next circles from CAD, I'm going to change this to a selected plane, and that's going to project everything that I measure onto the selected plane. So I select my projection plane, and now that I've got my projection plane selected, I can form circles from CAD cylinders. So I'm going to do that, and I'm going to go, we'll start with the large one, and then we'll do the bolt pattern, and then the large center circle here. So now I've got my task list entirely set up. I'm actually ready to go into the shop and start measuring these parts. So if you go to the inspection tab, the first thing that you'll need to do is do a new instrument alignment. We've got already got our instrument here. I'm going to switch to our instrument toolbar just to give us a little bit more visual graphical space here. And so on my instrument alignment, I'm just going to go to a new alignment because it's a new file. I haven't done one yet. And it's going to be a measure nominal points. So there's my nominals group. And you can see that SA brings up those 6 points that I created previously, and we're ready to measure them. So I don't know which point goes with what, so I'm going to turn on my point labels here just by pressing Alt-L in the screen here. And now my point labels are on, so I know which one I'm going to be measuring here. And I'll set my target as the 1.5 inch SMR with a 1/4 inch pin nest. That creates a 1 inch total offset and an 1/8 inch radial. And I'm going to be just taking single points here. So I'll place my SMR in the correct location for point 0. I'll just go ahead and hit measure manually. And we'll go to point 1 and measure that. And then point 2 and measure that. Now, if I wanted to, I can continue measuring these in order, Or I could just say use closest point after the initial locate, and then SA will automatically correlate the point that I've measured with the nominal point. It'll know based on its location. So then I'll just go to 0.5 here. Even though it's set on 0.3, it should tell me that this is 0.5. Yeah, so 0.5 pops up. And I'll go back to 0.3 and measure again, and 0.4 and measure manually. So now I've measured all 6 points, and because this is obviously a simulation, we got a pretty close. SA is going to insert a little bit of error automatically when it stimulates a measurement. So we're all within 1/10,000th of all of these. So I'm pretty happy with my instrument locate. I'm just going to hit finished locate instrument. And now we're located to our part. And so the next thing would be to just go to our task list here and begin measuring each one of these. So I've got a plane here, and from the normal inspection routine, I just go and I measure 3 or 4 points along this plane. Then I go to the next one, and you can see as I progress through the task list, SA will highlight. So if we go back to the plane, it's highlighting the feature that I need to measure there. Just take 3 or 4 points and create a plane, and then just take 1 point for each one of these circles. And SA will figure out, based on the single point at each circle, it'll calculate the diameter, and it will calculate the location of that circle projected to that plane, and you'll be ready to create your report. So that's a really simple way to do it. Creating a single point circle is not necessarily the most accurate way to measure diameter. But if your diameter, if you have a little burr on the corner here, or if you have a chamfer or something like that, then single point circle is probably not going to be the best way to measure. But just for certain features that you're not really too concerned about the diameter, then this is a great way to speed through your inspection. And just take a few simple points and get both your diameter and your location from that. So that's it for today. Thanks for